Today we are going to quickly review the basic concepts of collision. In this chapter, today we are going to take up the first thing is what is meant by collision. The next one is impulse, what is meant by impulse. Third one is line of impact. Then what is meant by line of impact. Next one is classification of collisions. After that, impulse of reformation, deformation, then one dimensional collision, elastic, inelastic, plastic collisions, that what we are going to briefly review today. First thing is what is meant by collisions, in what way it is going to be useful in physics. Particularly collisions are the events, any event where interaction between the bodies, colliding bodies. Colliding bodies may be many, 1, 2, 3, any number of bodies may be there, need not be only collision between two bodies. Number of bodies may be involved in the collision. Collision is a process or event in which large interaction force acts between the colliding bodies during a very short interval of time. What is meant by large or short? It is always relative. When compared to the forces colliding bodies experience before their collision, whatever the forces they experience, when compared to that during collision time, the force experienced by them is very large. That's why during collision event the interaction force is large. Interaction force means one colliding body exerting on the other colliding body. So that is the collision interaction force. Such force is very large when compared to otherwise force acting on the bodies other than collision time. That is one. During a short interval of time, what is meant by short interval when compared to what? When compared to the forces, when compared to the time of observation of the colliding bodies. During the time of observation, bodies may be moving. Over a longer interval of time, when compared to the time of observation, time they are going to interact is very small. Such event where large interaction force during a very short interval of time, particularly this large interaction force and the short interval of time, they are very difficult to measure and observe. And what we will be able to make out may not be able to exactly observe actually how the collision is taking place. But event before, event after clear-cut demarcation makes the event collision has taken place. For example, a cricket ball is being hit by a cricket bat. Cricket ball and bat, definitely we know that bat is hitting the cricket ball. But during that time, we will not be able to exactly see with our eyes how the cricket ball is hitting the bat or bat is hitting the ball. But we will be definitely able to make out that cricket ball is being hit by the bat, because before the collision ball was moving towards the bat. Within no time the ball has changed its direction and we will hear lot of sound where the bat is hitting the ball. Event before, event after by clear demarcation indicates that event has taken place. Such an event where the large interaction forces during a very short interval of time make it a collision. Collision as a process. Now, in this case, as I told you, need not be only two bodies involved. There may be many bodies involved. Okay. Therefore, the bodies number, there is no requirement that only two bodies are involved. Similarly, they need not be physically in touch. Colliding bodies need not be physically touching each other. Particularly in the case of ball-bat collision, definitely ball and bat physically touch each other. But in physics, we will come across events which are called as collisions. Is one of the examples is alpha particle scattering in the Rutherford's experiment. In the case of Rutherford's experiment, alpha particle beam is directed at gold foil, and we observe that according to Rutherford's conclusions, many of the alpha particles go in different directions. Some under large angle deviation they undergo, some undergo no deviation at all. When one in very large, 1 in million alpha particles, they are undergoing completely reflection, 180 degrees deviation. So, indicating that there is this event, this alpha scattering by the gold nucleus is considered as collision. So, why it is called collision? In this case, none of these alpha particles actually physically touch the gold nucleus, but this event as collision. The reason is alpha particle beam directed at the gold nucleus with high energy, alpha particle goes to nearer to the gold nucleus. Because of large repulsion, gold nucleus has a positive charge, alpha particle also is positively charged. There is going to be a strong Coulomb repulsion, makes the alpha particle to get deflected in different angles. When compared to the observation of the alpha particle motion, the time it spends nearer to the gold nucleus is very, very small. And before the event, alpha particle was moving along a particular line, but after the event, alpha particle is going in different directions. Event before, event after, we have clear demarcation. If you consider this as gold nucleus and alpha particle is approaching like this, alpha particle in different alpha beam, when we consider alpha beam and different directions, alpha beam will go like this, different directions it will go. Therefore, but 1 in alpha, 1 in million may be turning back. In all these cases, none of these alpha particles touch the gold nucleus, but this event we call it as collision. The reason is large interaction force, Coulomb's interaction between alpha particle and gold nucleus. Event before, event after. Event before, alpha particles are moving towards right. Event after, they are found at different angles, including 180 degree angle alpha particles are observed. Therefore, event before, event after, clear demarcation is there. And when compared to the time of journey of the alpha particle, time it spends nearer to the or in the vicinity of gold nucleus is very small. Because of that reason, even though there is no physical touch between alpha particle and gold nucleus, this event we call it as collision. There is also another event where identity of the colliding bodies need not be maintained in the collision. Identity of the colliding bodies is lost. For example, in the case of proton, a proton that is denoted by hydrogen nucleus, a proton directed towards silver nucleus, aimed at silver nucleus with high energy, almost to 25 million electron volt proton, high energy proton is aimed at silver nucleus. What happens? Though silver nucleus is positively charged, proton is also positively charged. Because of high energy of the proton, it will be able to overcome the repulsive force of the silver nucleus. But because of that, what happens? It is going to enter into silver nucleus. It penetrates into the silver nucleus, gets into silver nucleus, forms a silver nucleus, excited silver nucleus. That is, this proton enters into silver nucleus and makes the silver nucleus get excited. It is called excited silver nucleus. This takes place in the order of 10 to the power of minus 6 seconds. During a time interval 6 seconds, 10 to the power of minus 6 seconds, alpha proton will be inside the silver nucleus and comes out as alpha particle and palladium nucleus. So, in this case, no longer proton and silver nucleus are there. Proton and silver nucleus both are vanished here. In that place, we will get an alpha particle and palladium. Means identity of the colliding bodies is lost, new particles are observed, but even then this event we call it as collision. The reason for this event to be called as collision is, one, there is a large interaction force here. What is that large interaction force? Proton is entering into silver nucleus where the proton is under the influence of silver nuclear forces. what we know is among the forces in nature, strongest of the forces are nuclear forces. Therefore, proton inside the nucleus experiencing that is nature's strongest forces. Such strongest force when how much time? Hardly 10 to the power minus 6 seconds during a very short interval of time. When compared to time of approach of the silver nucleus, time it spends inside the silver nucleus is very small. Then after that what is happening? Event before, event after. Event after has alpha particle and palladium. Therefore, clear distinction is there, event before, event after. Therefore, this event we call it as a collision. Similarly, there is another collision we come across in physics where the event we call it as collision, though there is no particles are present. Say for example, there is one event where a positron and an electron, one is called particle, electron is a particle, positron is called its antiparticle. Antiparticle in the sense same amount of charge, positive charge, but mass is same as that, electron and positron, particle and antiparticle. When particle and antiparticle come under suitable conditions close to each other, in that place they vanish and a gamma ray photon is emitted. This is not a particle, photon is energy. Alpha, this is one electron, positron interact with each other, give rise to a photon. Means in this process both electron and positron are completely vanished, particles are lost. In that place we are getting energy. This event also we call it as collision. The reason is here large quantum mechanical forces, exchange interactions will act in the particles and give rise to energy. That is entirely particles are lost, even then we call it as collision. Event before, event after, clear demarcation is there. Event takes place during a short interval of time around 10 to the power of minus 8 seconds. So that is the lifetime of positron. This event we call it as collision, that is forward. That is called pair annihilation process. This is called pair annihilation, where electron positron pair are lost and photon is emitted. There is another type of event that is also collision, that is reverse process. A gamma ray photon under suitable conditions will give rise to a pair of particle and its antiparticle, that is electron positron pair are created by gamma ray photon under suitable conditions. This reverse process is called pair production process. In the case of pair production process, energy is converted into matter. In the pair annihilation process, matter mass is converted into energy. The reverse process here, where gamma ray photon is giving rise to electron positron pair, this event also we call it as collision. Though there were no particles was earlier, but there are particles now, that is also we call it as collision. Therefore, collision as event in which large interaction force during a short interval of time, event before, event after, clear demarcation makes the event to be called as collision.